Objective A. Multiplying radical expressions. Number 1. Radical 19 times radical 19. By applying the formula, we could put them together and rewrite that as radical 19 times 19, which is 19 squared. And then apply inverse operations, square root and square their inverse operations, and we got our answer, which is simply 19. Number 3. 7 radical x plus 2 squared. In this case, we are going to distribute that square outside into the inside. So you could do little curves like this. The first factor, 7 raised to the second power, and then the second factor, radical x plus 2 raised to the second power. And then we calculate each of them separately. 7 squared, that is 49. Radical x plus 2 squared, because you have inverse operations, square root and the square cancel out, you get x plus 2. Don't forget the grouping symbol. And then we're going to distribute 49 to expand this expression. We have 49x plus 98. Number 5. Radical 5 times radical 5 minus 1. This one is just like a monomial multiplied by binomial. We distribute radical 5. Even though this is not polynomial, but you could understand it like that. So we will distribute. First part is just radical 5 squared. Second part is just radical 5. The first part, you have inverse operations. Cross them out. And we got our final answer, 5 minus radical 5. Number 7. Radical y minus radical x times radical y plus radical x. You could use FOIL if you wish, but I have a better idea. We have the formula which says a minus b times a plus b is a squared minus b squared. Why don't you just apply this formula? Because this expression satisfied the formula. If I apply the formula, I will get radical y squared minus radical x squared. And we have inverse operations, so cross them out. And you got your answer, y minus x, rather quickly. Objective B. Divide radical expressions. Find the quotient and simplify, if possible. Number 9. Radical 30 divided by radical 5. We have a formula to combine the quotients of the radicands. So I could place both radicands together as a quotient and put them underneath the same radical sign. Radical 30 over 5. The benefits of doing this is I only need to deal with radical parts once. 30 divided by 5 is 6, so I have radical 6. 6 is not a perfect square. It doesn't have a perfect square that's a factor of 6, so that's our final answer. Number 11. 3 radical 28y to the 10th over radical 7y to the 6th. Same idea. Instead of simplifying each radical parts, I put them together. So we have 3. It's on the top. And then you have a huge radical sign. Inside the radical sign, I'm going to put both the top and bottom together. You have 28y to the 10th over 7y to the 6th. I'm going to simplify that quotient. Numerical part, 28 and 7, they have a common factor of 7. So I divide both of them by 7. 28 becomes 4, 7 becomes 1. Y to the 10th over y to the 6th, they have a common factor of y to the 6th. So I cross out this y to the 6th, cross out the 10, and write down 4. Because that's the difference between 10 and 6. And then I'm going to write down what's left. 3 radical, there's nothing left in the denominator. We only have the numerator, which is 4y to the 4th. We only need to simplify this. I'm going to put the numerical part and the variable part in separate radical signs. And that simplifies to 3 times 2 times y squared. And of course, if you're experienced, you could skip the putting them in separate radical signs and get your answer right away. And that simplifies to 6y squared. Number 13. Number 13, they already have the quotient underneath the radical sign. Let's see if we could simplify that. Well, we cannot simplify. They don't have any common factors. So that means we're actually going to distribute that radical sign to the top and to the bottom. On the top, I have radical 121, radical n to the 10th. At the bottom, we have radical n to the 4th. Simplify each of them. They happen to be all perfect squares. 121 is 11 squared, so it's just 11. M to the 10th, it has even exponents, so it must be a perfect square. You simply divide the exponent by 2. Same thing with the denominator, it's simply n squared. And that will be your final answer to number 13. Number 15. Radical 11 over radical x. This one, first of all, 11 and x, they don't have any common factors, so we cannot put them together and simplify. Second of all, we have a radical number in the denominator, which requires us to do a procedure called rationalization of the rational expression. Since we only have a radical factor in the denominator, the way to rationalize this entire expression is simply multiply both top and bottom by the denominator, radical x. Let's do the denominator first. Radical x times radical x, that's radical x squared. The numerator becomes radical 11x. Radical x squared, you could simplify that, cross out inverse operations, and that becomes x. Numerator still 11x underneath the radical sign, and that is our simplified version of the original expression, which is rationalized. We don't have any radical numbers in the denominator. Number 17, radical w over 52. Since we cannot simplify w over 52, no common factors except 1, we're going to distribute the radical sign. Radical w over radical 52. And I'm going to simplify that denominator. I will rewrite that radical 52 as radical 4 times radical 13. You could do a tree diagram if you wish. That might help you finding out the factors. That's a perfect square. And that simplifies to radical w over 2 radical 13. And again, we have this radical part, radical 13 in the denominator. We have to get rid of that. So I multiply both the top and bottom by that radical part, which is radical 13. Let's write the next step right here. And if you multiply straight across, on the top, we will get radical 13w. The bottom, we will get 2 times radical 13 squared. Cross out the inverse operations in the denominator. We have radical 13w over 2 times 13. And again, I'm just showing you all the steps. For experienced user or experienced math student, you could just totally skip some of the steps that I show over here and then skip to the next. And the final answer is radical 13w over 26. Sometimes the rationalization might be a little bit more complicated, which we will see in the next few examples. For example, number 19, we have radical 6 plus 5 over radical 3. So same idea, we have a radical number in the denominator. To get rid of that, we have to multiply both the top and bottom by that radical number in the denominator. In this case, it's radical 3. And then let's simplify. I'm going to do denominator first. Radical 3 times radical 3, that's radical 3 squared. Or you could just simplify, simply write as 3. On the top though, you have to distribute radical 3 because we have two terms in the denominator. So that is the difference between what we did before and what we're doing right now. If I distribute radical 3, I will have radical 18. Or why don't I rewrite that 6 times 3 as 3 times 3 times 2 plus 5 radical 3. So I rewrite 6 as 3 times 2. It's because 3 times 3, you have that perfect square right there. And that simply becomes 3 squared times 2. So you have a perfect square right underneath that. And then I can break down into two different radical signs and rewrite that as square root of 3 squared times square root of 2 plus 5 square root of 3. Now let's simplify it. Cross out inverse operations in our expression and write down what's left. On the top, we have 3 radical 2 plus 5 radical 3. On the bottom, we have 3. And that is our final answer to number 19. Number 21, 7 over radical 3 plus radical 12. This time we have two radical numbers in the denominator, radical 3 and radical 12. To get rid of this denominator, we need to multiply both top and bottom by something called the conjugate. Conjugate by definition, you will use the same radical numbers, radical 3, radical 12. Instead of having a plus in the middle, you will do the opposite, which is minus. And you have to do the same thing on the top as well. So we will multiply by this rational expression. And then let's calculate. For the denominator, you're going to apply the formula a plus b times a minus b equals a squared minus b squared to quickly find out the answer. So in this case, it's going to be square root of 3 squared minus square root of 12 squared. On the top, you distribute 7 into radical 3 minus radical 12, and that will give you 7 radical 3 minus 7 radical 12. Let's simplify this. The bottom one becomes 3 minus 12 because we have inverse operations. You could cross them out. The numerator, there's one thing that we can simplify, which is that square root of 12. So you could break that into 7 square root of 4 square root of 3. Further simplify, denominator becomes negative 9. Numerator, we have 7 radical 3 minus 7 times 2 radical 3. That's 14 radical 3. Further simplify, the top becomes negative 7 radical 3, applying distributive property. Denominator is negative 9. The two negative sign becomes positive. So you have our final answer, 7 radical 3 over 9. Objective D. Solve applied problems involving the multiplication or division of radical expressions. 23. Chemists study the motion of gas molecules called diffusion. The rates of diffusion of two gases are related by this formula, where M1 and M2 are the masses of the molecules of the gases. Find the ratio R1 to R2 if M1 is 45 units, M2 is 9 units. Express the answer as a simplified radical. We are given this formula, so let's write down the formula. R1 over R2 equals radical M1 over radical M2. And we plug in the values that they gave us. M1 is 45, we have radical 45 on the top. M2 is 9, so radical 9 on the bottom. Of course, you could simplify each of them, but there's a quicker way. We could combine the radicands, put them as a quotient. So it's the same as radical 45 over 9. 45 over 9 is very easy to calculate, it's simply 5. So we got our final answer, radical 5, right away, and you don't need to do anything else. That concludes this section. Thanks for watching.